Okay, so we're going to go over section 11.1, beginning of the chapter, and the entire chapter is titled Areas of Plane Figures. So we're going to be talking about the entire chapter, the subject of areas. Now, area is kind of an interesting um, piece of mathematics because there is no method to accurately or directly to measure area. So, as I always start off this discussion, how is it or what is it that area is? Um, what is it that you think it is? Um, so often people will say the top of a table or a top of the desk or whatever, but it's really a pretty interesting concept that mathematicians have come up with here. So let's start with an easy object here. And if we, ooh, that's terrible. Um, if we just start with a figure that you're used to here, a square, um, if I can draw a nice square here, then it's usually where we start out talking about area. So if we have this square here, which is all right angles, um, we actually define area in terms of square units. And that's kind of an interesting thing in and of itself because we can have square units of area, but I think it's fairly obvious we could have a circle here, and this circle has area as well. So even though this doesn't have a square, or it's not a square, it can have area. A triangle similarly can have area here, but it too does not have to be a square. So why we use a square is a little bit interesting. So how we're going to talk about this is this. If we assume that, let's say this is 1 centimeter here, over here, and this side too is 1 centimeter, then it follows that we say this is a 1 centimeter square. And that follows. Everybody gets that, I think. But again, going back to this concept here of area, there is no device to measure area. So what I want you to think of is heat. So if you have a temperature, you use a thermometer to measure temperature. If you're driving a car, you look down on the speedometer, you are measuring, or your speed or velocity is being measured for you. There is no way to find this. So area is one of these things in math that we say is derived. It's a derived quantity, and that's a really important concept in mathematics. Area is derived, which means it has to be calculated. That's very different than something like temperature, which we measure. There is no way or device to use to measure area. We can measure temperature, but area, like other types of quantities in math in the physical sciences, has to be calculated. And I think that probably you already know how to do this. If we look at this figure up here, which is, if it's drawn well, is a square, and I said it's 1 centimeter on one side and 1 centimeter on the other side, and I said this is a 1 centimeter square, then it would kind of follow that this is a square centimeter, which is how that expression comes from. But we derive this quantity, like I said. This is a derived quantity, so we actually take the length times the width, and that equals area. And we use the units here. The length here is 1 centimeter times the width, which is 1 centimeter. Now that equals, mathematically, 1, and this is important, square centimeter, which is really pretty cool. Now, the issue here is, like I said, and even though I've already erased my circle here, that if we think about it, a circle can, of course, and does, of course, have area. And we could have little squares inside here, but eventually if you get to the edge of the circle, then we don't have full squares. So that's a little concept that we'll talk about later. But we can also go back to our unit here, our square, and say, well, if we divided this up like this, and instead of these, or this whole side being 1 square unit, now I'm going to say something different here. I'm going to say that each one of these squares instead is 1 centimeter. Okay? And this over here is 1 centimeter down to here. That makes this square area 1 square centimeter in area. It also makes this side 2 centimeters here. And it would make this length over here 2 centimeters. Now, that means that each one of these is 1 square centimeter, right? 1 square centimeter. 1 square centimeter. But that means the whole thing here now is 1, 2, 3, 4 square centimeters. And we can also get this by multiplying 2 times 2, which equals 4 square centimeters. And that should make sense because we have 4 individual squares, each one of which is 1 by 1, which is 1 square centimeter. So the total, adding these up, will be 4 square centimeters. So I always take a little time to introduce this when we talk about area. Now, calculating, to be honest, is pretty straightforward and pretty simple. You're going to have some definitions, postulate 19, straight away, that talks about the area of a region is the sum of areas, which means simply that you can add areas together as long as the units are the same. You cannot add square centimeters to square inches and so forth. If two figures are congruent, then they have the same area. And it's not a hard reach to now go to the next more, if you will, complex diagram, and that's a rectangle, in which case, of course, one side is different than the other when you have a length and a width. And similarly, we still say square centimeters, in which case we're dividing this box up, this rectangle, into square units, which is actually kind of interesting. You have a homework lesson for this section. Hope that helps you, and good luck with the homework.